Hi guys, this is Snow. In this video we create Tetris in Java. Well, why Tetris? So I wanted to create something simple for a change since my last project was pretty big. So I was wondering what would be a good subject and realized that I had never developed Tetris before. I know it's a pretty common subject and many people have done it, but I had never done it myself, so decided to try it out, and it turned out pretty okay, so I decided to share it with you guys. If you have followed my previous tutorials, especially my 2D tutorial, this shouldn't be so difficult, and if you have any questions, feel free to leave a comment. So let's start. First, create a project. I'm gonna name it Simple Tetris, and then create a package, main, and inside of this package create a class, main class. And first we create a window like this. So we use a Java class called JFrame. I named it window. And set a window title here. And set the default close operation so we can discard this window properly. And set resizable false. So the window size is fixed and cannot be resized by users. And set location to null. This means we don't set any specific location on the screen, so the window just shows up at the center of the screen. And finally set it visible, so the window is gonna be visible on the screen. Without this line, you cannot see the window, so make sure to add this line as well. Now let's create a new class. And I'm gonna name this game panel. And this class extends JPanel, so it has all the functions of this JPanel class. First, let's set the screen size. So I chose 1280 by 720, so this will be the screen size. And here we set this width and height on this game panel and set its background color. I chose black, but if you like, you can choose other colors. Also, we don't use any preset layout, so we can customize the layout as we want. And now let's go back to the main class and add this game panel to the window. So this is how we add JPanel to JFrame, this window. And when you add the panel and pack like this, basically the window adapts to the panel size. So let's run the program and check it. Okay, so now our game panel is set on the window and the size is 1280 by 720 and the background color is black, so we can draw stuff on this black panel. So let's go back to the game panel and now we create a game loop. So game loop is for updating the screen at regular intervals, and in this game we set 60 FPS, which means we update and draw the screen 60 times per second. So let's set FPS. And also declare thread. So we use this thread class to run our game loop. And to use a thread, we need to implement a runnable interface. So if you have watched my previous videos, I know this sounds redundant, but please bear with me. I just wanna provide some basic information in case people who have never watched my videos are watching this one. And when you implement runnable, you need to add a run method. So here it says add unimplemented methods. Then we get this run method. And then we start this thread. So any method name is fine. Init, launch, start. I chose launch game because we launch the game here by activating this thread. So we instantiate our game thread and start it. And when a thread starts, it automatically calls this run method. And before working on this run method, we add two methods. So in every game loop, we basically do two things: update and draw. So update means update object positions, X and Y, or maybe your score. So basically all kinds of number information. And draw means draw. So draw objects or UI text, stuff like that. So now let's create a game loop in this run method. And for the game loop, I'm sorry, but I won't explain how it works in this video because the game loop itself can be the topic of single video. Also, I've already made a detailed game loop explanation video before, so if you don't know much about game loop, please check my game loop video or any other videos on YouTube. I'll put the link in the description. Anyway, here I'll just type the game loop, but as long as it works, any game loop is fine here. Alright, so that's the game loop. With this, the program calls this update and repaint method 60 times per second. And it's a bit confusing, but this repaint basically means calling this paint component method. So we call these two methods from this game loop. So the game loop is done. Let's create a new class. I'm gonna name this Play Manager. And this class is gonna handle basic gameplay elements such as drawing the UI and setting Tetrominoes. So first we're gonna draw the main play area. Okay. So I'm gonna place the main play area at the center of the window around here. And the width is 360 and the height is 600. So we're gonna do this a bit later, but we're gonna set a single block size as 30 pixels. So that means we can place 12 blocks horizontally and 20 blocks vertically. Also declare 4 variables that indicate left, right, top and bottom of the frame main area. So let's create a constructor and set these numbers. So to get the left x, so I subtracted the half of the play area width from the center point of the window. And the right x is left x plus the play area width. And for the top y, 50 pixels. And the bottom y is top y plus the play area height. And then we're gonna create two methods. And we're gonna call these two methods from the game panel. And for this draw method, we pass this graphics 2D. Go to the game panel. First we instantiate the play manager class. Then from this update method, we call the update method in the play manager class. And from this paint component, we call the draw method, but we need to pass the graphics 2D. So here we need to convert this graphics to graphics 2D like this, and then call the draw method in the play manager class and pass this G2. Alright, go back to the play manager. So let's draw the main play area. So first we set a color and then set the stroke width. So you can pass any number you want and then draw a rectangle. So to draw a rectangle, we pass x, y, width and height. So I used these variables. Okay, then what are these -4 or +8? So I modified the values a bit because I set 4 pixels for the width of the frame. So I want to make this left x boundary of the frame where collision happens. So that's why I subtract the frame width from the left and the top and add 8 to the width and height. Let's check. Yep. So yeah, left x is here, not here. Then let's draw another frame. Like this. This is like a waiting room for Tetrominoes, so we can see what Mino will be coming next. Also, let's add the text around here. Yeah, something like this. Let's check. Oh, what? Anti-use rendering mail is not compatible. What? Oh, text. Yeah. So we set a font on this G2, then set anti-aliasing, and then draw the text. So text and x and y. So we have created the play area and next Mino area. So let's create a Tetromino and display it on the screen. So first create another package. I'm gonna name this Mino. Then create a class. Block. So what is this class? Well, in Tetris, every Tetromino is composed of 4 blocks, and this class represents a single block. So we combine 4 of this block and create Tetrominoes. So first, this class extends rectangle. So this class is pretty simple. So it has x and y, the size, and the color information. So I set 30 for the block size. And in the constructor, we receive color information because each Mino will have a different color. And we have a draw method here as well, and it draws the block with its color. And that's basically everything about this class. So let's create another class. I'm gonna name it Mino. So this will be the super class for all Tetrominoes. So all the different shaped Tetrominoes will extend this class. So first we create 2 block arrays. And we create a method called create and instantiate these arrays. Then create these methods. Set xy, update xy, and update and draw. And this Mino class is okay for now. Next we create all the different Mino classes. Mino L1, Mino L2, Mino T, Mino bar, Mino square, Mino Z1, Mino Z2. 1, 2, 3, 4, 5, 6, 7. Yeah. So in Tetris, you have 7 different Tetrominoes, and I call them L1, L2, and T, bar, square, Z1, and Z2. Okay, let's work on this L1 Mino, and this class extends Mino. Okay, in this constructor, we call the create method in the superclass, this one, and pass a color. So this will be the color of this L1 Mino. I chose orange, but you can choose whatever color you want. Then we get the default X and Y of this Mino here. So this L1 Mino looks like this. So as you can see, it is composed of 4 blocks. So we use this block array to set their X and Y. Yeah, like this. So we receive x and y and set them on this B0. And here's the important part. So this B0 is not this one, but this one, because we can rotate this Mino, but this block's relative position doesn't change. And so this is B0, and I chose this one as B1, and this is B2 and B3. And so this B1 is above B0, so the x coordinate is the same, but the y coordinate is B0y minus block size. And B2 is x is the same, and y is B0y plus block size. And B3 is this one, so x is B0 plus block size, and y is B0y plus block size. So this way, whenever we update these x and y, so we can automatically update other three blocks too. So now let's go back to the Play Manager class. Mino. So we declare a Mino class and name it current Mino. Also create these integers to store its starting x and y. And the starting position is around here. So at half width of this play area to the left x, then subtract a block size. So the start x will be around the center of the play area, and for the start y at a block size to the top y. Okay, so let's set the starting Mino. Yeah, like this. So since we only have this L1 Mino now, so I set it as the current Mino and pass the start x and the start y. So this L1 class receives these xy here and set all these blocks x and y accordingly. And here we call the update method in the Mino class. So okay, let's draw this current Mino. So first we check if this current Mino is null or not, otherwise we might get null pointer exception errors, and then call the draw method of this current Mino. So that is this one. So in this Mino class we draw the Mino, and for the color we use this color we set for these blocks. So we draw 4 blocks using these x and y. So okay, I think so we recording this, so yeah, let's check. Okay, yeah, so our first Tetromino has appeared on the screen, but I kinda don't like how this looks. Right now all these 4 blocks are seamlessly connected, but I want to change it so we can see each block. And to do that, we add a little value to these parameters. Yeah, like this. So I created a 2 pixel margin and modified it this X, Y, and width and height. So this way we can draw a bit smaller block without changing its actual data X and Y. So yeah, let's check. Yeah, like this. So I like this better, but it's just a preference, so you can choose either look. Okay, now let's move this Mino. And first we implement auto drop function. In Tetris, the current active Mino keeps dropping down at certain interval. So let's do that. In display manager, we add another integer. So I set the drop interval 60. 60 means 60 frames. So the Mino drops in every 60 frames or 1 second. And okay, in this Mino class, add some variables. So we create a variable called auto drop counter, and in this update, increase the counter. And when this counter hits the draw interval, this Mino moves down by 1 block. Yeah, so like this. So we add block size to each block's Y, and after that reset the counter. Yeah, let's check. Oops, what? It's not working. We calling this update, right? Why? Why it's not called? Ah, okay. Sorry, I think I haven't called this launch game method. Yeah. So we need to call this launch game. Otherwise, yeah, thread doesn't start. So okay, let's call it from here. gp.launch game. Sorry about that. Okay, let's check. Okay, yeah, now the Mino is going down automatically. Yeah, looking good. So now let's move this Mino with our keyboard. Yeah, key handler. So create a class in this main package. And this class implements key listener. And when you implement this key listener, you need to add 3 methods: key typed, key pressed, and key released. But we don't use this key released and key typed at all. We only use this key pressed method. And also we use some boolean. Okay, then we get the key code. Okay, so whenever you pressed a key, you receive this key event, and you can get a key code from it. And if the pressed key is W, then up press boolean becomes true, and so on. So I chose WASD for movement, but you can choose other keys too, such as up key, up, down, left, right. Alright, and now add let's add this key listener to this game panel. Okay, so this way, whenever you press a key while the window is focused, so you can get the key input with this key handler class. And then go back to this Mino class. So let's control the Mino. Let's take care of this down first. So if you press down key, then yeah, like this. So when down pressed is true, the Mino goes down by one block. And after that, we reset the auto drop counter. So change the boolean to false. So let's take care of the left and right too. Alright, yeah, like this. So when left is pressed, so we subtract x by a block size, and when right is pressed, we add the block size to the x. Okay, let's check. Yeah, so now we can move the Mino with the keyboard. Yeah, no collision yet though. And finally, the up. And this is a bit tricky because this handles Mino's rotation. And to do that, first we create a variable. Yeah, so each Mino has 4 directions. And we indicate that with this integer variable. So 1, 2, 3, 4. And then create 4 methods. So around here. And we can leave these blank here. So we override them in each individual Mino class. So for example, in this Mino L1 class, so this L1 Mino can be rotated to 4 directions. Okay, so let's copy this. And direction 1 is basically the default direction, so this one. We type like this. So this time we use this temp B array and put the x and y coordinates, so same as this one, and then call this update xy method in the superclass, and pass this direction number. And so here we basically we put these temp B values into this B array, where then you might think, so what's the point? Why don't you just directly update this B array instead of using this temp B array? Because we need to handle collision. So if collision happens when we rotate a Mino, we need to cancel the rotation. But if we have already updated these x and y, we cannot restore the original position. So that's why we just stored these values in this temp array. I will explain a bit later when we handle the collision. So, but right now this is how it is. Okay, so let's handle other directions too. so this is the direction 2, and this time this is the B0, so the center block, and this is B1 and B2 and B3. So based on this B0 we can get other, x and y. Okay, then direction 3 and 4. Yeah, so direction 3 and 4 are like this. So now we can rotate this L1 Mino to 4 directions. So go to this Mino class, and so when you press this up key, then okay. So if the current direction is 1, and if you press W key, then we call this get direction 2 method, and if the current direction is 2, then we call this get direction 3, and so on. So every time you press W key, the Mino rotates. Okay, so let's check. So press up key, yeah, like this. So now we can rotate the Mino. So let's create other 6 Minos. And basically these classes are very similar. The only difference is the shape. So we set different relative coordinates. So it's pretty repetitive, and I think I will just fast forward the process and occasionally stop it so you can check each Mino's x and y positions. Okay, so here we go. Okay, that's the Mino T class. And so this bar has only 2 directions. So we can simply call direction 1 and 2 from here. And this square is even more simple because it's square. So basically we cannot rotate it. So we don't need to add anything here. And okay, two more. So Mino Z1 and Z2. And this Z1 and Z2 too have only two directions. So we call direction 1 and 2 from direction 3 and 4. Okay, that's everything. So now we have 7 minnows. So let's pick a random minnow from these 7 minnows. So play manager. So here we create a method. Okay, so we use this random class and pick up a random number between 0 to 6, and based on the number we return a different minnow. And here, so instead of setting L1, we call this and get a random minnow. So let's check. Okay, so square, yeah, and we can rotate it. Oh, wait, something is wrong with this. L2, I think. Let me check. Something is wrong. Maybe this position, maybe. Oh, X, Y, X. Okay, sorry. This is Y. X, Y, X, Y, X, Y, X, Y. X, Y, X. So this two. And this two. Oh yeah, this one too. Okay, let's check. Okay. Yeah. Okay, now it looks okay. And yeah. Okay, everything looks okay, I think. But as you can see, there is no collision yet. So let's implement it. So in this minnow class, we create 3 booleans and then 2 methods. So there are 2 kinds of collision in this game. So we check collision when the minnow moves or rotates. So first let's take care of the movement collision since it's easier. First we reset these booleans and then okay, so first the left wall collision. So here we scan the block array and check its x value, and if it's equal to the play area's left x, then that means the minnow is touching the left wall, so we set the left collision true. And the right wall collision happens when this minnow's x plus block size. So okay, let me see. So this minnow's x plus block size is equal to the right x, and bottom collision happens when this minnow's y plus block size is equal to the bottom y, and we call this method okay, I think should be around here. So before we handle down, left and right movement, we check if the minnow is touching the wall or floor or not. And so if one of these collisions are happening, then the minnow cannot move. So let's handle that. Yeah, like this. So the minnow can go down only when the bottom collision is false. Yeah, like this. So the minnow can go left only left collision is false, and can go right only when this right collision is not happening. And yeah, 2 equals. So let's check. Okay, so yeah, left collision, right collision looks good. Yeah, but when we rotate the minnow, it ignores the wall, so we need to check the collision when we rotate the minnow as well. Also, the bottom collision is working, but it still doesn't prevent the old drop, but we'll take care of that a bit later. So let's handle the rotation collision first. And before doing that, let me implement a pause function. So key handler, and here we add pause pressed. Yeah, something like this. So I use a space key for the pausing. So when you press space key, the boolean becomes true or false depending on the current condition. Okay, then this game panel, and here I think. So we only update the on-screen information when the game is not paused. And okay, let's draw a text when the game is paused. So play manager. Okay, here. Yeah, like this. Let's check. Okay, so now we can pause the game. And okay, so right now we can rotate the Mino, ignoring the collision. But that's not good. So, for example, when the Mino is in the position like this, then we shouldn't be able to rotate this. So we need to check if it's gonna hit a wall or not. And if it does, we need to cancel the rotation. So in this Mino class, and when you hit this W key, up key, we call one of these get direction methods. For example, assuming this get direction 1 is called, so we first check if this rotation is possible. And so here, update XY. So before updating these X and Y, we call this check rotation collision method. And also at this if statement, yeah, so if no collision is happening, then we can rotate this Mino. But if collision is happening, we don't update these X and Y. And now let's work on this this one, check rotation collision method. So it's actually very similar to this check movement collision. So I think we can copy this and paste it, and then change this B to temp B, because we check the collision using these temp values. And also this is not equal, but if left x is greater than this x, and also this is right x is smaller than this x plus box, and this is bottom y is smaller than temp y plus block size. Okay, let's check. Collision, so here, no, we can't do this. Here, yeah, we cannot rotate anymore. And like this, so we cannot rotate. Or, yeah, we cannot rotate. And next we add some code, so when a Mino hits the bottom, then it stays there and a new Mino appears at the top. And to handle that, we create another boolean. So and okay, here, where is it? We change like this. Yeah, so if the bottom collision happens, we deactivate the Mino and bypass the auto drop. Okay, so let's check. Yeah, so now the Mino stops. Alright, then let's display the next Mino. So play manager, and here are some next minute data. Okay, so we create another Mino, next Mino, and it's X and Y. Also create an array list. So we put the inactive Mino into this static blocks. And okay, so let's set this X and Y. So somewhere around here, and create a next Mino like this. Like this. Pick a random Mino and pass this X and Y. And then draw this next Mino. So draw. Like this. Okay, so let's check. Okay. So let's put this inactive Mino into this static blocks array. So okay, here update. Create an if statement like this. Yeah, so like this. So we put the current Mino into the array. Then like this. So we replace the current Mino with the next Mino, and pick a new next Mino, which will be displayed in the waiting room. And then we draw this static blocks array too. So here, all right. So we scan this list and draw it one by one. Okay, let's check. So, yeah, it's working almost. Yeah. Okay. I think I forgot to add margin to this block class too. Okay. Okay, let's check. Okay, now looks better. As you can see, we need to implement collision with these static blocks too. So let's create another collision check method. So here, and call this from both check rotation collision and this check movement collision. And here, first we scan the static blocks array and get each block's X and Y, and using these target X and Y, we check down, left and right collision. So we check if this Minoes y plus block size is equal to one of these static blocks y, and also this time we check this x value too, and this means a static block is right below your Mino, so bottom collision happens. Okay, that's everything. Now we should be handle this static block collision too, so let's check it. Alright. Yep. Okay. Yep. Looks good. So now all the collisions are working perfectly. However, we have a slight problem. So maybe you have noticed, but when a Mino touches the floor or a static block, it immediately becomes inactive. But if you have played Tetris, you know it shouldn't be like that. You should still be able to move the Mino even after touching something. So in a situation like this, you want to slide this square Mino to the left so it fits nicely. But we cannot do that right now. So to make this sliding possible, we need to create some time margin. So we create this boolean and integer variables, and when the bottom collision becomes true, instead of immediately making it inactive, so we set this deactivating boolean true, and at the start of this update method, we check if deactivating is on and call a method deactivating. So let's create this method. Yeah, something like this. So we increase the deactivate counter, and if it hits 45, we reset this variable and check the collision. And if the collision is still on, still happening after 45 frames, we set this Mino inactive. And also play manager, we reset current Mino dot deactivate. Oh wait, this is public. Okay, let's check. Yep. Okay. Alright, then now delete lines. So okay, we create a method and call it from here. So basically what we need to do is count the number of the block on a line. And the maximum number of blocks that can be placed in a row is 12. So if we could count 12 blocks in a single row, that means we can delete them. And to do that, we scan this play area by a block size, and if there is a static block, we increase this block count. So okay. And while scanning the play area, we scan this static blocks array too, and if it's x and y are equal to this x and y, that means there is a static block at this coordinate. So we increase this block count. And also so we reset the counter when x reaches the right x, because it goes to the next row. Also, when finishing this row, we check if the block count hit 12. If so, that means this row is completely filled with static blocks, so we can delete the line. Yeah, like this, I think. So here we remove all the blocks that have the same y, and for the scan, we check the slot from the largest number. So if this array list has 10 blocks, then it will be slot 0 to 9. So we start 10 minus 1, so slot number 9. Yeah, so if you scan from 0 to the maximum, like usual, this loop doesn't work correctly because we are removing slots. And when you remove a value from an array list, then the variable positions is also shifted by 1, and it produces some weird results. So we check from the largest number, and after removing the blocks, we shift down all blocks above this line by 1 block. So if the block's y is greater than the current y, we add the block size to it. So it goes down by a block. Okay, let's check. Yeah. Okay, looks good. Let's try multiple lines. Okay, now we can. Alright. Okay, looks good. So now we can delete lines. So the game mechanics is basically done now. So we can play the game, but still it looks a bit too simple. So we're gonna add some decorations and some effect. So I think it would be better if we could see some effect when we delete lines. So to display an effect, we use boolean, integer, and array list. And okay, so when we where is it? When we delete line here, when we delete a line, so we set this boolean true and add the current y to this array. We use an array because it can be multiple lines that we delete. So if we can delete 4 lines, then we need to get 4 y values. Okay, then let's draw the effect. So draw method. And so here we check if the effect counter is on, and if it is, increase the effect counter and set the color. Then create a for loop and scan this effect y array and draw a rectangle which is as wide as the player area width, and the height is the same as 1 block. And finally, when the timer hits a certain number, we reset everything and stop drawing this effect rectangle. And I set 10 frames, but you can choose any number basically. Okay, let's check. Okay. Okay. Not that impressive, but not so bad, I guess. Oh, and we haven't implemented game over yet, so let's take care of that too. We create boolean, and okay, so when we deactivate the minnow, the current minnow, we check. So when we deactivate a minnow, we check if the minnow hasn't moved from the starting position. If so, it means we have no space left to move the minnow, so the game is over. And so let's draw game over text. I think we want to display at the same, at the center of the play area. So and okay, so else if, and also I think so we are not using this space, so left side space, so I think I'm gonna draw the game title just for the decoration, and I'm gonna use new font. And also italic. Okay. Let's check. Okay. A little bit to the right. Yeah, like this. Okay, and let's check the game over too. Okay, game over. And okay, we need to stop the game. So then a game panel. Okay, so here. Okay, yeah, we are almost done. And let's add score and level. So without score and level, the game is not so fun, isn't it? So play manager. So we create variables like this and okay, draw. So we draw score frame. Okay, yeah. And then draw some text. Okay, like this. Yep. Okay. And then in this check delete, create an integer line count. And okay. So here. So when we remove a line, we increase this line count and also this lines. And then okay, at the score, so at the end of the method, we add score based on the number of the lines that we have deleted. And I set the single line score as 10 times current level. So if the current level is 3, you can get 30 by deleting a line again. Okay, and also we need to increase the level. So here, I think. Okay, and also let's increase the drop speed. So here's another little touch. So this line score increases every time you delete a line, and if you deleted 10 lines, so every 10 lines, oh, this is not 10, this is 0, sorry. So every 10 lines the level increases, also the drop speed, and basically every time you gain a level, the drop interval decreases by 10. So it starts from 60, and then 50, 40, 30, 20, every time you level up. But then when you gain a level when the drop interval is 10, then the drop interval becomes 0, and that simply doesn't work as a game. So if the drop interval is 0, then the game is no longer playable. So to avoid that, when the drop interval is 10 or less, we decrease it only by 1. So 10, 9, 8, 7, 6, 5, and so on until it hits 1. But of course this is just an example, so feel free to think and set your own score mechanics. Okay, let's check. Okay, score increased. Delete 10 lines, then we can gain a level. Okay, level 2 now. dropping speed increases a little bit, I think. Alright, then the final touch. So let's add music and sound to enhance the atmosphere. So I prepared these audio files. Background music, it is called White Labyrinth. And also I prepared 4 sound effects that I made myself with Beepbox. Sound effect for delete line, game over, rotation, and touch floor. So right click on this project and create resource folder and copy this file here. Then create another class in this main package, sound. So first we create clip and the URL array, and then constructor. So in this constructor we get the file path of these audio files and put them into this URL array. Then create a method called play, and we receive integer which will be the slot number of this array, and also a boolean. If we are playing a music, not sound effect, then this boolean is true. So this is like a template to get the audio file. So what we are doing here is using this file path. We get one of these audio files and put it into this clip object. And okay. And if this is music, not sound effect, then we pass this clip to this music clip because we'll use it in other methods. Then we open the clip by passing the AIS. Wow, that's a lot of selections. So choose this one. Javax sound sampled line event. So then we add this line listener to this clip. So I didn't do this in my previous tutorials. So this is something I learned recently. So what we're doing here is setting a behavior for when the audio is finished. So when the audio is finished, we close this clip. If you don't do this, your computer's memory usage increases every time you play an audio, and the memory gets stuck. So this is one way to free some memory. And finally, we close AIS and start the clip. So we can hear the audio. And we create 2 more methods. Alright, so these are for music. If it's music, we want to loop the song and maybe want to stop it when the game is over, or so we pause the game or something like that. So we prepare this loop and stop methods. So that's everything about this sound class. So go to game panel and okay, so instantiate the class. So here we create two static sound objects. The one is music and the other one is SE, sound effect. And first let's play the background music. So maybe it starts when we launch the game. You're gonna call the play method in this music and pass a slot number and also boolean, and this is music, so boolean is true. Then we loop it. Okay, let's check. Okay, so now we can hear the music. So let's implement sound effects too. The first one is rotation sound. This one up key, W key. And so we're gonna play the sound. Maybe here. Dot SE. So this time we use this SE class, not music. And play and pass the slot number, and this time not music, so false. So touch the floor means bottom collision. Okay, so here so like this. So we play the sound when the bottom collision is true, but only when this deactivating is false. So we play this sound once, then this deactivating becomes true, so we won't play this sound anymore. So we only play once, because without this if statement we keep hearing this sound until this bottom collision becomes false. So we need this if statement. Oh wait, so like this, and I realized I passed a different number for this up key. Wait, so rotation is number 3. Sorry, not 1. 1 is delete line and 2 is game over. Okay, sorry. So the next is a sound for deleting lines. So delete line. Delete line is not here. Play manager. So delete line may be here. So here. And finally, game over. So game over is here. So first we stop the music and then sound effect. And also I want to stop the music when we pause the game. So in that case I think we should do it in this key handler. So when we press this space key and when we resume the game, play and 0 and true, and also make it loop. No, music.loop. Okay, maybe that's it. That's everything. I think the game is now complete. So let's try it. Okay, rotation sound. Okay, line delete sound too. Level 7. My gosh, it's really fast. Oh, what to do? What to do? What to do? What to do? Oh, it's so fast. Okay, level 10. Ah, no, I don't think I can make it. Ah, no, 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 wait. Damn. No, 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 no. Ah. Yeah, okay, so that's the end of this tutorial. So we have created the Tetris. I hope you enjoyed this video and enjoyed coding. As I said at the beginning, Tetris is a pretty popular subject for coding, so this is just one way to do, and I bet there are many other ways to do this. So feel free to arrange this and explore your own way. Anyway, that's all for today. Thanks for watching this long video, and yeah, until next time, bye.